Hello and welcome to StudyIQ. I am your friend Rahul Saigaonker. Let's continue our discussion of NCERT Science series. You already know we are discussing NCERT Science textbook for class 9 where we are doing a chapter by chapter analysis. Till now we have completed first 3 chapters, chapter 1, 2 and 3. And I told you these initial chapters are going to be the base of your chemistry knowledge. What have we established till now? We discussed about the meaning of matter. We established that matter is composed of tiny particles which we cannot see with our naked eye. We name them atoms. We understood certain characteristics of these tiny particles. We also discussed about different kinds of matter, pure substances or pure matter. We categorize them as elements and compounds. Impure matter or impure substances are nothing but the mixtures, heterogeneous mixture, homogeneous mixture. We discussed about solution, colloid, suspension, their characteristics. How do we separate stuff? That was also discussed. And in our latest interaction, we discussed about different atoms and molecules and their characteristics. Today, we'll move ahead to chapter 4, which is structure of atom. This is going to be a very interesting chapter where we are going to understand how we have developed the atomic structure module. We'll understand about the discovery of atomic structure. We all know in scientific discoveries, different experiments are conducted, assumptions are made, and various scientists have tried to explain the concept of atom. Slowly and steadily, our idea of atom has evolved more and more. We'll understand what is that knowledge today. So let us begin our interaction. But before we head into the content, there is a small notice for all of you. If you are preparing for UPSC Civil Services examination, or if you know anybody who is likely to prepare for this exam, who are interested in becoming IAS and IPS, do let them know about our program Prelims to Interview Initiative. First English batch by StudyIQ. It is beginning on 19th of June. It is the most comprehensive program which has the complete package. We will prepare you for prelims, mains and interview. If you clear your preliminary examination 2024, your entire mains residential program and its expenses would be taken care of by StudyIQ. We are developing this model of preparation on the basis of Gurukul. You will be called to the StudyIQ center where you will be preparing with the faculty, with the members for your mains, focusing only on answer writing. So just go to our website www.studyiq.com. You'll get all the details there. If you want maximum discount, use my code Rahul Live. I'll see you in the class soon. All right, let's begin our discussion today. As I told you, today's interaction is about structure of atom. Until now, we have established certain things. In the first 3 chapters, we focused on understanding matter and nuances connected to matter. And in chapter 3, we discussed about atoms and molecules. And these are the fundamental building blocks of any matter. Now, scientists were thinking, we discussed that from the perspective of chemical reactions, of course. Now, scientists were thinking, how does this atom look like, or what is the structure of this atom? They were trying to explain different models. We also spoke about different laws, conservation of mass, conservation of definite proportions. Now, they were trying to explain it through structure of the atom. And various scientists, they started to work by the end of 19th century to reveal what exactly an atom looks like. And different scientists have given their models by refuting the previous model. One of the initial models was given by John Dalton, of course. Right? We discussed about John Dalton. John Dalton, that is the English scientist, he came up with the idea of matter, and he said that matter is composed of very small things, and he called these small things as atoms. And that is why his model is also called as billiard ball model. Billiard ball model means he did not give any kind of explanation about the structure of matter per se. He simply said that matter and its smallest constituent is nothing but atom. Indeed, he was right. He gave certain assumptions, rules and regulations. He said all matter is composed of atoms, and atom itself is indestructible. Agreed. Atom is indivisible and indestructible. And atoms are something that give properties to the elements. It is because of the atoms the matter has physical and chemical properties which are specific to it. And as we spoke about chemical reaction, in a chemical reaction, it is nothing but a rearrangement of these particular atoms. We have established the rules and regulations regarding Dalton's atomic assumptions. That is why it's called a billiard ball model, where he simply said atom is something like this, but he did not go in depth of it. And by now we already know, of course, atom is indivisible and indestructible, but we know an atom is composed of subatomic particles. They are called as protons, neutrons, and electrons. So that is why Dalton's atomic model, it fails to explain these subatomic particles. It fails to explain why chemical reactions take place. It fails to explain the involvement of electron or electron transfer in the rearrangement of these atoms. That's why the next model came. The next model came in 1904 by J.J. Thomson. Now, J.J. Thomson gave a different model. Instead of the billiard ball model, he gave the concept of a plum pudding model. His model of atom is called as plum pudding model. Now, he said that yes, atom is indivisible. Atom is the final constant, or matter is made up of atoms which are indivisible, indestructible, but it has charge. It has charge, right? And J.J. Thomson said that atoms, it consists of something called as electrons, and these electrons are negatively charged. And because of the transfer of these electrons, the chemical reaction or rearrangement of atoms, it does take place. Yes, true. But now, if there are electrons, if there is negative charge, then it also should have positive charge. So J.J. Thomson, he knew that overall an atom is neutral. That means it will have neutral charge. If there are electrons, then there has to be some sort of a positive body or a positive charge also. And in a very simplistic way, J.J. Thomson explained, since there are electrons, these negatively charged bodies are electrons, and these electrons, they are diffused, or they are spread in the cloud of positive charges. This red thing is a cloud of positive charges, and in it different electrons are there. A very simplistic model. But slowly and steadily our knowledge did refine. Dalton did not talk about electrons or positive charges. He simply spoke about an atom. But J.J. Thomson spoke about electrons, presence of negatively charged bodies. But even this model, it does not explain everything, because there are many limitations to Thomson model. Of course, he came up with the negative charges, that is electron, yes. But he failed to explain how the positive charge, those are held inside the electrons. Because if the positive and negative charges, they combine, they neutralize each other. But then why atom is reacting again? Why some element undergoes multiple reactions? It fails to explain. It fails to explain the stability of the atom. Because by this time, the concept of nucleus had not evolved. The concept of nucleus, it did not evolve. J.J. Thomson mainly failed to explain the concentration of positive charges somewhere in the middle of the atom. He said that electrons are basically spread in the spherical cloud of positive charges, but it's the other way around, basically. Right? It's other way around. We know that by now. But this is called plum pudding model because it looks like a pudding. Right? It looks like a British pudding, but this is the pudding, and there are the constituent or the nuts. They are like the electrons, right? Right. The next model, or more refinement, it came with Rutherford's model. Ernest Rutherford, he conducted certain experiments to understand where are the charges exactly residing. What are the characteristics of the atom through experimentation? He tried to improve Thomson's model. Thomson had given this model, but there were many limitations, and they were Thomson's plum pudding model. It was refuted by Ernest Rutherford. Why? Because he conducted an experiment. He conducted an alpha ray scattering experiment. He scattered alpha ray on a gold foil, and he observed how these alpha rays are deflected. Now he observed that when alpha rays are passed through this gold foil, some of the alpha rays, they did not deflect at all. In fact, he said majority of the alpha rays, they did not deflect. That means when I talk about a gold foil, now we are discussing about gold atom. In a gold atom, many alpha rays, they did not scatter at all. They simply pass through the gold foil as it is. But there were some alpha scattering. There was some alpha scattering which was observed. Whenever alpha ray interacted with the electron, it scattered in some direction. When it interacted with the positive charges, it scattered in some direction. And he observed that many a times the alpha scattering was exactly 180 degree. That means the scattering was reversed also. So based on this experiment, Rutherford came up with a conclusion. He concluded that in an atom, basically the gold foil, it consists of some sort of a central charge where the charges are concentrated, and he named it as nucleus. This is also called as the nucleus theory or atom theory, which talks about nucleus. Now Rutherford explained that the positive charges are held at the center of the atom. These are the positive charges, and many alpha ray, they interact with this. They are scattered, yes, but many alpha rays, they are also reflected back exactly 180 degrees. And he said electrons are revolving around this nucleus in circular orbits. This is also called as the planetary model of atom. Means the nucleus is like the sun, and electrons are revolving like the other celestial bodies or the planetary bodies, satellites, etc. And he said that alpha rays, they do interact with electron also, but this scattering was minuscule. That's why he said that most of the charges and most of the mass of this particular atom is concentrated in the center, that is nucleus. He said the bulk of the mass and bulk of the volume itself is concentrated in the nucleus, and electrons, they basically revolve in a circular orbit around the nucleus. Very similar to how planets are revolving. Again, we refined our knowledge. But there are certain limitations to Rutherford model also. The first and biggest disadvantage or limitation of Rutherford model is he also failed to explain the stability of an atom. He failed to explain the stability. Although he said, yes, nucleus is at the center, and he said the electrons are revolving in a circular orbit. But he also said that when electron revolves in this orbit, in the circular orbit, he said the revolving electrons, they also emit energy. Now, please try to understand this. If this is going on, if they are accelerating, if they are emitting energy, then there would be one point where this electron is going to lose all of its energy and it is going to collapse in the nucleus. Then what? If it collapses in nucleus, what happens? Why are these electrons exactly revolving in these circular orbits only? How are they stable? Why are they emitting energy? All these things were not explained. Apart from that, he also failed to explain in totality the chemical kinetics of a reaction. As I told you, the electron interaction. If it loses energy, then it is going to fall. How is it stable? There was no answer. And then came one of the best models that was developed by Niels Bohr. Now, Niels Bohr model, it is inspired from the planetary idea itself of Rutherford. Rutherford's model has been refined by Niels Bohr. Now, Niels Bohr said that in an atom, of course, like Rutherford said, Ernst Rutherford, nucleus is at the center and nucleus has positive charges. Now, if there are positive charges, then nucleus should also contain something else, because if there are positive charges considered, you do know positive charges, they repel each other. If there are protons, then they will repel each other. So there are protons also, and this nucleus is maintained because of charges called as, because of constituents or entities called as neutrons. So nucleus consists of protons and neutrons together, which are held very tightly. And now electrons are revolving. Like Rutherford said, electrons are revolving in a circular orbit. So this is also a kind of a planetary model. But now Niels Bohr described that these electrons, they revolve in different shells. That means they revolve in different orbits. And these orbits, these electrons are held in this orbit by electrostatic force. But why do these electrons emit some sort of energy? For that, Niels Bohr explained that many times electrons, if they are in the ground state, he described an electron to be in ground state if that electron is in its own shell. He explained that around the nucleus there are different shells, K shell or K orbit, L orbit, M orbit, N orbit. So different orbits or different shells, they were named differently, and every orbit or every shell has different energy. According to Niels Bohr, the farther the electron in the orbit or in the shell, it will have more energy. And he said many a times an electron, it might jump from the lower energy state to a higher energy state. This is called as excited state. Now in the excited state, the electron cannot remain perpetually there. So it will try to come back to its original state. And when it comes back to its original state, it has high energy, it has to come to lower energy state, it releases photons, it releases the energy. So this is what was explained by Niels Bohr, and this is one of the closest explanation. This is the accepted notion that we already know. So Rutherford's model was further refined by Niels Bohr, and Niels Bohr spoke about different orbitals or different shells in which there are electrons. And in fact, based on this itself, we have developed the different shell configurations. Apart from this model, more refinement did come to the Schrodinger's quantum atomic model. Now, this is called as the quantum atomic model. Although this is not mentioned in NCERT, if I recall it correctly. So, Schrodinger's quantum model, it simply says that yes, of course, there is nucleus, and this nucleus consists of protons. These are positive charges. Neutrons are also there. Neutrons are chargeless, but they do have mass. Neutrons provide stability to the nucleus because it is holding positive charges together. And he said electrons can be seen as a cloud around nucleus, not exactly as shells, but they can be seen as a cloud, because electron would be traveling at the speed of light, electron would be moving very, very fast, and it is as if the negative charges, it consists of an electron cloud. Now, this model was further refined by a lot of quantum physics laws, right? Although Erwin Schrodinger, initially, he solved the Schrodinger's equation, giving the notion of electron in a central electric field. He spoke about nucleus, right? Nucleus, and electron is in a nuclear field. So he solved the equation, Schrodinger equation. Apart from that, quantum atomic model was further strengthened by hypothesis by de Broglie. He said that all particles in the matter, all particles in the atom, that is the electrons, they can be perceived as matter waves with a definite wavelength, that is the de Broglie wavelength, right? And based on this itself, we can talk about Aufbau principle. Aufbau principle, it gives you the idea of why an electron is present in that particular shell. Apart from that, the quantum atomic model talks about electron cloud. Now, when we talk about electron cloud, can I pinpoint that an electron is present here? If it is revolving, it may be present here, it may be present here, it may be present here, it may be present here. And what is the energy of this particular electron? And for that, Werner Heisenberg, he gave Heisenberg's uncertainty principle. It states that the energy and the position of an electron cannot be defined exactly. I cannot know where an electron is and what is the energy both together at one point of time. That is called as uncertainty. The more I know about the energy of an electron, the less I know about its position. And the more I know about its position, the less I know about its energy. Apart from that, Niels Bohr's ideas were also taken. So eventually, what we know today, the solid sphere or the billiard ball model of John Dalton. From there, we move toward J.J. Thomson, that is the plum pudding model. From there, we move to the planetary model given by Ernest Rutherford, Niels Bohr, and then eventually Erwin Schrodinger, giving the quantum atomic model. These are the characteristics of it. This is for your reference. I'll be sharing the PDF of this particular lecture on my Telegram channel on the ID @Rahul Sai 222. You can always refer to it. So what have we established till now? We have established that atom consists of a nucleus which has positive charges, and electrons are revolving around it. And electrons are in different shells, different orbitals. So how are these electrons distributed? Now, according to Niels Bohr and according to the other quantum atomic models, the electrons are distributed in different shells according to different principles. The maximum number of electrons present in any shell, it can only be 2n square. That means 2 into, if it is a first shell, then there would be only 2 electrons in it. If it is a second shell, that means if we talk about different shells here, K, L, M, N orbit. So K orbital, it is going to have only 2 electrons. L orbital, it is going to have the next number, that is 8 electrons. The next orbital, it is going to have 18 electrons, and these electrons are shared according to their energy in different suborbitals on the basis of Aufbau principle. On the basis of this itself, we will be talking about the reactivity of these atoms and elements. But the other rules include the maximum number of electrons that can be accommodated in the outermost orbit is 8. This is called as an octet. That means every atom or every element, it tries to obtain this octet. If there are exactly 8 electrons in the outermost shell, it is going to be most stable. Apart from that, electrons are not accommodated in a given shell unless their inner shells are filled. That means first the K shell has to be filled, then only the L shell would be filled. These are some of the rules and regulations. And based on this itself, we talk about the concept of valency. Valency. I gave you an example in our previous interaction that valency or valence electrons are like the hands that we have. I told you humans have two hands. That means I can grab two things. I have this slide mover on one side, the pen or the stylus on the other side. But imagine an octopus. Octopus has 8 tentacles, so it can hold on to 8 things together. So its valency is more. So valency or valence electron is like the number of electrons it can catch or number of electrons it can give away, so that it reaches the most stable phase. My most stable phase is holding these two things. I can hold more things, but they may fall off. So valency or valence electrons is the same kind of concept, where the atom, it tries to achieve something called as an octet. That means in its outermost shell, outermost orbit, if 8 electrons are reached, it is going to be stable. So valency is the electrons in an atom which are arranged in different styles, and the electrons that are present in the outermost shell, that is called the valence electron. And the number of valence electrons, it defines your valency. For instance, if you look at different atoms, hydrogen has 1 proton and 1 electron. And remember, hydrogen is the only atom which does not have any neutron. All the other atoms, you will find neutron. Hydrogen has only 1 proton and 1 electron, right? 1 proton and 1 electron. So what would be the valency of hydrogen? Its valency would be 1, because it would like to lose that electron to someone. If there is another atom or an element which is trying to look for 1 electron, hydrogen is going to immediately react with it. That's the basic understanding of valence electrons. Similarly, if you look at the structure of lithium, beryllium, boron, carbon, you will find that the best example would be neon. Now, if you look at neon, you will see that it has a nucleus. Yes, there are 2 electrons in the K shell, and there are exactly 8 electrons in the L shell or L orbit. Now, this is going to be most stable. That is why neon, it does not react much. Why? Because it has already achieved the octet. Now, the concept of octet means if there are electrons in it, say hydrogen has 1, it would likely lose it, because there is a very low probability that there is some other atom or an element which is likely to lose 7 electrons. Now, for hydrogen to reach the most stable phase, now for it, the first shell would be adding one more electron to it. But let's take some other example. Say, what is the probability? If there is only 1 electron in the outermost shell, then either it can accept 7 electrons to achieve stability, or if it has 1 electron, then it can lose 1 electron to achieve that stability, isn't it? Then what is the probability? What is the higher probability? This one, because I wouldn't find an atom or an element which is likely to lose 7 electrons, because that would love to accept 1 electron and reach its octet stage, right? And that is how you'll understand when you look at these atoms. There's a list given in the NCERT, where hydrogen, for example, hydrogen, the atomic number is 1, the number of protons is 1, there are no neutrons in it, its valency would be 1. Similarly, for helium, its valency would be 0, because its outermost shell is going to have exactly 2, and the outermost shell is already filled, right? Because the K shell is already filled. But if you look at any other element, for instance, look at nitrogen, oxygen, fluorine. Now let's look at these 3 numbers, where you'll understand that its valency. Carbon has a valency of 4, oxygen has a valency of 3, nitrogen has a valency of 3, oxygen has a valency of 2, and fluorine has a valency of 1. Now the question is, why fluorine has a valency of 1? Let's look at fluorine here. Why fluorine has a valency of 1? If you look at its first shell, K shell, there are 2 electrons in it. In the next shell, there are exactly 7 electrons here. Now the question is, will fluorine lose these 7 electrons or will fluorine accept 1 electron? The more probability is it is going to accept 1 electron to complete its octet. That means its reactivity will be very, very high. The same case with neon, neon would have 0. Wherever you will find 0, they are the most stable atoms or elements which do not have a lot of reactivity. I hope the valence electron or valency concept is clear to you. Just remember the idea of octet, that means the outermost shell, it has to be fulfilled. In the K shell, if there are 2 electrons, it's fulfilled. In the L shell, if there are 8 electrons, it would be fulfilled, the octet, right? And to get these 8 electrons, either it will accept or it is likely to lose. All right, right. Let's move on. Now we have established what is the structure of atom. There is a nucleus which has protons. These protons are held together tightly. That is why there are neutrons also. Protons are positively charged, neutrons no charge, but neutrons do have mass. Then there are electrons which are revolving. Okay, again, according to quantum atomic model, there is an electron cloud with the probability of electron finding anywhere in that particular region. So the atom is composed of proton. Proton is present inside the nucleus. It has a positive charge. It has a mass also, definite mass. A neutron, this is present inside the nucleus. There is no charge. There is no charge. It has mass. In fact, neutron is the heaviest of the subatomic particles. Please remember, neutron is even heavier than proton. Clear? There is a small difference between mass of proton and neutron. Remember, mass of a neutron is slightly higher than mass of a proton, and because of this difference, it is called as mass defect or mass deficit, we get the nuclear energy. We'll talk about this in our subsequent discussions. And then there is electron. Electron is outside the nucleus. It has negative charges. Its mass is almost negligible because it is of the order of 10 to the power of minus 28. All right. Now, based on this, protons, neutrons, and electrons, structure of atom is defined. Now, we also defined number of atoms, they lead to formation of an element. Now, elements are defined based on the number of protons and neutrons in it. Every element, we have seen the periodic table, every element is defined through 2 characteristics. When we write an element, we write the atomic number below and we write the atomic mass or mass number above. So if I write one particular element, I signify it as the X, and I told you how is the nomenclature held. There are certain rules and regulations. We normally take the first letter or the first 2 letters or first and the third letter. I have told you about that. The English names, what is the nomenclature rules. I defined this particular element by atomic number and atomic mass or mass number. What is the atomic number? Please remember, atomic number is the number of protons present in that particular element. Number of protons in the atom of that element. Atomic number. Mass number is number of protons plus number of neutrons. Please remember, in this atomic mass and atomic number, there is no concept of electron. The electron or its characteristics are not used in calculation or in finding of atomic number and atomic mass or mass number. Clear? So you must have seen here in this particular list, if you look at this, if I say hydrogen has how many number of protons, that would become its atomic number. Just look at this, you will see the number of protons, it is going to be exactly same. The atomic number is going to be same. But the number of neutrons, when you add these two, you will find the mass number. That means for hydrogen, if I add this plus this, that means the atomic mass number or atomic mass would be again 1. That is why I write hydrogen as 1H1. Similarly, helium, it has atomic number of 2. That means number of protons is 2, number of neutrons is 4. So how do I write helium? I would write helium as 2He4, because the atomic number of protons is 2, number of neutrons is 2. Add these two, you will get 4. Similarly, if you look at oxygen, number of protons is 8. So its atomic number becomes 8 and its mass number becomes, just add number of neutrons, just add these two, you will get, for oxygen you will add 8 plus 8, you will get 16, right? So this is atomic number, this is the atomic mass to designate that particular element. Is it clear? Now many a times what we see is there are certain elements which have same atomic number but different atomic mass. Many a times we see there are different atomic numbers but same mass number, and those are called isotopes and isobars. Remember, isotopes are the elements which have same atomic number but they have different mass number. Classic example would be carbon. We know that carbon 12 is also present, we know carbon 13 is also present, we know carbon 14 is also present. So these are the isotopes of carbon, and this isotope of carbon is used in radiocarbon dating. Now what is the meaning of this? All the three are carbon, all the three have same atomic number. That means all the three are going to have same kind of chemical characteristics, right? But there is an addition of neutron. In carbon 12 there are 6 neutrons, in carbon 13 there are 7 neutrons, in carbon 14 there are 8 neutrons, because this is constant, that means it is number of protons, so number of neutrons has increased. So isotopes are one which have same atomic number but different mass number. When you reverse it, you will get isobars. Now isobars are atoms with different atomic numbers but same mass number, right? You can get, say for instance, now if you look at this, we have carbon 14, I told you, but we also have nitrogen, right? So isobars, there are different atomic numbers but same mass numbers. So isotopes are those where the atoms have, basically these are the atoms of same element, they are not of different elements, but these are the atoms of different element. I give you example, carbon 14, then 7 nitrogen 14, different elements, they have same atomic numbers, they have same mass numbers, right? Here atomic number is same for isotopes, here carbon 6 carbon 12, 6 carbon 13, 6 carbon 14. My example here would be 6 carbon 14, then 7 nitrogen 14, a very good example here, right? But do remember that isotopes, the chemical properties of isotope are similar but physical properties can be different. But for isobars, they have different physical and chemical properties. MCQs can be formed on these. Clear? Right. So this was the basic discussion of structure of atom, valence electrons, and isotopes and isobars. That's the end of our chapter 4. We'll meet next time in our subsequent discussion. But do remember, if you have liked this discussion, if you have any queries, any doubts, do follow me on this particular ID. You can always connect to me on Instagram. I do respond on Saturdays and Sundays. And do not forget to subscribe to our channel, StudyIQ IAS English. Do like the videos and share the videos as well, because we want more and more people to take benefit from this particular initiative. Thank you again. Jai Hind.